Alright, students, let's look at this question here, which is on parametric equation taken from the year 2007, paper 1, question 11. This is actually from the actual H2 Math A-level national examination. So we are given the parametric curve of x equals to cosine square t and y equals to sine cube t. For this parametric equation is defined by this, and we are told to sketch a curve. I think sketching the curve is pretty okay. The first thing is to take note that this is make sure you limit the window setting here. So I think a lot of students would just forget to actually limit the window settings. Okay, so if you look at that, I'll just go to mode, change the parametric, and in this case here, what we're gonna get is actually just cosine t, so cosine t square, and then this case will be sine t to the power of 3. Okay, make sure you change the window settings. So the window settings is actually 0 to pi over 2, so I'm going to just put pi over 2 here, and I'm going to graph it. So obviously I'm going to zoom box to the area where I like to use zoom box. So you just click and drag to this area here in the middle, where the graph is, the actions going on there. So just this is the graph that you're looking at. Okay, so just plot this graph, should be fine. So once we sketch this, just take note, do we need to, so usually what I'll say to students is just check the extreme, the lower bound and upper bound of the, what they call it, the domain there. What we're going to do is actually just key in trace, press 0, and you will get 1, 0 here. So this is pretty okay. We get 1, 0, 1, and after which I'm going to just put in pi over 2, trace pi over 2. There'll be, pi over 2 is 0, trace 0 will be 1, 0. Sorry, so this is 1, 0. Okay, now the good thing about parametric equation is good if you just know that which parameter correspond to which point here. So I usually will say just put this as t, trace 0. This is t pi over 2, and know that this point corresponds to t equals to 0. Okay, it's very important to know what is the parameter acting behind the point. Okay, so let's look at part 2.